Okay, so we ended with even and odd functions yesterday. I want to do some review from this is still from the old packet. We have one more page there. And this will be your homework tonight. Your homework will be pages 11 and 12. The key is attached immediately after. Okay, so what I want to do is just to be able to we'll work out some of the problems together, but it's more of kind of walking through the steps and identifying, wait, is this a expansion power problem or is it U-substitution? Because not every problem is going to be U-substitution. We always want to consider our expansion possibilities first before we go and jump into U-substitution. And I think the hardest part of U-substitution problems is the first part. If you can identify what the U value is, then everything kind of falls into place, and you know that you're just trying to get it to match one of the rules. Maybe we'll do the first one, but then after that, I just want us to set things up and identify the U value. Okay. Maybe I'll do the more difficult ones with you and leave the ones that are more manageable for you to finish at home. So number one here, first things first, can we expand our way through and rely on power rule? Now, it's possible, but what's a little what's a little messy here? Yeah, that 5, right? Having to write binomial out 5 times and expand one at a time, that just takes too long. If it was degree 2, then we can definitely expand our way through, but anything greater than 2, we want to look for a better option. So our next option is U-substitution. Then what could be our U value? Yeah, 5x plus 4. So the whole purpose of U-substitution, it doesn't really, the whole purpose is to create an easier looking problem so that we can take the antiderivative, right? So the whole purpose is trying to make it so that it's easier to work with. Okay, so our U value is 5x plus 4. Du dx. What's the derivative? 5. We solve for dx. Dx equals du what? Okay, we make our substitution here. This gets replaced with u to the 5th times du over 5. Okay, where can we put that 5? Outside as 1/5. Okay, are we ready to identify a rule for us to use? Yeah, what rule is this? Power rule, right? So integral of u to the n du, u to the n plus 1 over n plus 1. So there's no x's left over. This matches our rule. We can apply the rule. The 1/5 is out of the way, so we know it's not going to distract us. 1/5 times. Yes, I'll tell you exactly the rules that you have to memorize. This is one that you have to make sure we know. Okay, and you memorized it for the quiz, so it's just we're just tacking that on. Okay, so u to the 5th becomes what? U to 6. plus c. Okay, so we have our antiderivative, but can we leave our answer like this? We got to bring back what? We started with which variable? X. So we want to end with X, right? So you can put that 30 below, or you can put the 30 outside. I like to put it outside as 1/30th. Replace the U with what? Raised to the 6, right? Let's see. Okay. Any questions with this? Okay, number 2. Why don't we do this? Why don't we just identify the first steps of what to do, whether it's expansion or U substitution, and then if we can find out the U value, then we can fill out the pieces later. So I want to just make sure we can figure out the first step, because that's always the hardest part. And then we'll do that for every problem, and then we'll come back and work on the ones that may be more challenging. So number 2 here, first things first, can I expand our way through? We could, but what's a little messy here? Yeah, that 5th power is a little messy, right? So what could be our, so we do want to go through U substitution here. What could be our U value? Okay. And is this going to be favorable? Is this going to work out nicely with the variables canceling out? Okay, why? Yeah, you got that degree 3, and that degree 3 will handle that degree 2 fairly easily. So U equals TQ plus 4. And then from there, you're going to do du over dt, and then keep going, right? And then d over dt is what? 3t squared, right? And then solve for dt, and then clean all that up. Okay, so the rest is just getting it so that eventually power rule will show up, and then we can work with power rule. Okay, let's look at number 3. Number 3, so I just want to get through the first steps for each of these problems, and then we'll come back to them. So number 3, square root of 4x minus 5. Can I expand and use power rule initially? No. So use substitution. But we want to see a set of parentheses. I don't see the set of parentheses. So how can I rewrite it so that I can see a set of parentheses? Mm-hmm. What's the U value? Yeah, 4x minus 5. Du over dx is 4, and then just 4, right? And then we cross multiply, solve for dx, put everything back, and then power rule can handle the rest of the way. Okay, number 4. Can we expand this through or separate into individual fractions and do power rule? Too many terms in that radical, right? So what could we do as our first step? Well, this is definitely U substitution, right? We can't just rely on power rule. So before U substitution, do we see a set of parentheses, or can we create a set of parentheses? Yeah, the 1/5, okay. Okay, this one, we're going to go through it the same way that we normally would. But there is something a little bit different about this once we get it all cleaned up. So we'll come back to this one. All right, let's look at number 5. Okay, number 5, do we have a rule that can handle this exactly as the way we see it? Yeah, we have a rule for cosine of u, but do we have a rule for cosine of 2x plus 1? It's a little more than what a rule can handle, but it should be fairly easy to get it into the correct form. We do have to go through substitution, what could be our u value? Okay. Okay, number 6. We don't have a rule that can handle that large of a process. Any idea what could our u value be? Megan? Yeah, so something like that, but I want to make sure that we don't ever do this. We don't ever assign u to be just x, even though we do see a set of parentheses. But if you just let u equals x, you're not making the problem any easier. You're just making a 1-for-1 swap. And with u substitution, it's always more than just an x, because you want to create an easier looking problem. Even if everything is in terms of u, you're not creating an easier problem. It looks exactly the same, and that doesn't help us, right? So we know it's not just going to be that x, even though the parentheses is there. Can we create another set of parentheses with our problem? Or let me ask you this: is there a way to rewrite this problem? Yeah. Where can we put that pen? Outside the sign, right? So it's the same thing, but visually, I think it's more helpful. And then from here, what could be our u value? Sin x. Well, do you think this cosine will take care of itself down the road? Yeah. If the u is sine, what's the derivative of sine? Cosine. Okay, let's go to the back page. Okay, number 7, a little bit too complicated for any one rule to handle. What could be our u value? Cosine x, right? We do see x in parentheses, but again, it's never just going to be x. It's going to be something larger. We see a larger set of parentheses below, and that's what we can do to target that. Okay, number 8, can we expand our way through this problem? Can't, right? So can we, so our next option is U-substitution. What could be our, or can we rewrite it so we can see a set of parentheses? Okay, what could be our U value? Now, some of these U values, we look ahead and we can see those U variables get replaced into the problem. Where are the here? Where do you see the U values being put back in the problem? Where's it located? Yeah, in the denominator. Can power rule work in the denominator? No. So down the road, we're going to have to eventually bring that U up to the top by changing the sign of the exponent before you do power rule. Okay, so just keep that in mind, that some of these, we go through your substitution, but when everything is said and done, we got to make sure that our U value is moved up to the top before you take power rule, before you apply power rule. Okay. Number 9. This one looks a little messier here. And this one kind of takes a little bit of trial and error to get through. Anyone have any guesses as to what the U value could be? 5 over x. Because I want you to turn to the other packet. There is a formula sheet, which is just a formula sheet for you to look at to so that you know what to work towards, but we do have to memorize these. We talked about how the derivative trig rules are just showing us where all the integral rules are, right? We read from right to left. Right? But to make it a little bit easier for you to see, the trig integral rules is really just down here, right? So if we were to read from right to left, we see there's a rule that says integral of secant u tangent u equals secant u. So we can kind of see that outline in our problem. We can kind of see where we're working towards, right? So if we let our u value be 5 over x for both of these, then eventually that secant tangent hopefully will turn into a rule that we can use. So, yeah. If we want to work through this a little bit more than what we have so far, if our u value is 5 over x, what can I do to find the derivative? Yeah, I mean, we could do quotient rule, right? But this is an easy one to avoid with quotient rule. We can say u is equal to 5x to the negative 1. Therefore, du over dx equals what? What's a derivative? Yeah, negative 5x to negative 2, right? Cross multiply. Solve for dx. And if I want to clean up, I can move that exponent, that negative exponent, so that it's up top. Let me show you what this will look like once I put everything back in. The 4 over x squared is going to stay. Replace the underlined portions. Do the x squared cancel out? Yes, right. It didn't look like it would cancel out with that x, but you see the x in the denominator, so the derivative does produce an x squared down the road, which takes care of that x squared below. What can I push out in front? Negative 4/5. Right? Do we have a rule for secant u, tangent u? Yeah, just secant u, right? Replace u back in terms of secant u, tangent u becomes secant u, the negative 4/5 stays, plus c, and then replace the u back in terms of x. Okay, so I want you to now go back to number 2 and see if you can continue working through, finish off the rest of our problems. I'll be right back. There's a key that you can check your progress as you work through. Okay, let me go back and to where we were and see if we can identify the first steps again, and I'll let you, we'll go back and work on finishing up these problems. So number 10, can we expand our way through? Yeah. No, right, okay, so U substitution, what's our U value?
7 minus x.
Yeah. Is this U value variable favorable to hopefully cancel stuff out? Yes, that x to the fifth is a good degree because we know the derivative will produce 5x to the fourth. That x to the fourth should help cancel out that x to the fourth up. The only thing you gotta watch out for is that your U values in the denominator. Eventually, before you apply power rule, just make sure that U is brought back up before you apply power rule. Okay, but okay. Number 11, can we expand our way through and rely on power rule? This one we can rely on power rule. This is the like a problem that you saw on the quiz where if I just distribute everything through, there's only one term in the denominator, split up into individual fractions, and then we do power rule, right? I know that you do see a set of parentheses there, but this is not a good fit for U substitution because if we can handle something using expansion power rule, we want to apply it, right? Otherwise, if you let the U value be 2x minus 1, you're not going to be able to get all the x to cancel out. Okay, so U substitution is not an umbrella rule that can handle everything. Okay, if it's meant for power rule, then that's the only way to go through it. We can't go through U substitution if the pieces aren't there for us to make it fit. Okay, split up into individual fractions. Subtract exponents to move the x's up to the right spots. 4 minus 1/2 is equal to what? Yeah. 3 minus 1/2. Okay. No need for U-substitution, right? Power rule can handle it the rest of the way. Right, add 1 to the exponent divided by the exponent. Okay, we can finish that later. Okay, number 12. Can we expand our way through? No. Okay, so U-substitution. Can I rewrite it with a set of parentheses? Yeah, parentheses raised to the what? Okay. The U value is easy to spot. Is this degree going to work out nicely with that x squared outside? Yes. Okay, let's go back to the first page and okay, I'd like for you to try finishing the rest of these problems, at least on the first page. And I want to kind of walk around to see, do you have any individual questions? Or do you have any trouble with setting things up or identifying the appropriate rule? Hoping that, identifying that U value is the hardest part of the problem and that you can kind of work your way through. So, spend the next few minutes. I want to see how you have any questions as you're working through this. Yeah, so
It's like 100.
what was it to? Well, cross multiply here. So here, if I cross multiply, I get 2 dx equals dv, right? And then solve for dx. Yes, so there's no x, so we're good. And then did we just okay, solve for dx. Underline the parts that I want to replace, right? Underline that, underline the dx. Put everything in and see what it looks like. Yeah, cosine x. That's no, cosine x is just remember we're only replacing this and this. Everything else is going to stay.
Okay.
And replace the u by cosine x. Okay. Yes. Any questions?
They're always looking for this property access, right? So you need to take out because that's the thing, you basically don't play on it, that's okay. That's always like non-barrier kind of thing.
Okay, so your homework, are just the 2 pages that we're working on. The key is attached on the back, so you kind of work your way through and check your work along the way. Tomorrow, you guys think of the test review packet. We didn't get a chance to go over it, but we'll start tomorrow. I want to highlight the topics that we're going to see. So power rule, just like the one we're working on, just like the ones that you saw on the quiz. U-substitution and change of variable. We worked through some U-substitution. Trig integrals, we saw some of that. Also depth integrals, unit circle values, you want to make sure we review those. Depth integrals, absolute value function, we haven't quite gone over this, but this will be an easy topic. Once you see it, it'll be easy to work through. And then the new topics, even odd functions, second theorem, average value theorem, and then PVA, just like how you saw on the quiz. Except instead of second derivative, I say acceleration. From acceleration, find your way up to position. The formulas you got to memorize are power rule, Drake integrals, just like on the quiz. And then the new ones, second theorem, average value theorem, and then the unit circle values. There's no limit definition of area, no sigma notation on the test. All right, go meet your folks.